right, it looks like it just finished building a virtual 3D correction LUT, and the completion time took 4 minutes and took 73 readings. We can go ahead and select OK. Now let's go ahead and validate the virtual LUT and see how well the display now would be performing with this applied. I'm going to select the color checker page. I'm going to go up to the cube generator, and I'm going to select Enable Virtual LUT, minimize this tab, and do a series reading. Now CalMAN is going to run the validation test with X-Rite's ColorChecker SG industry standard color pattern set. While this is running, let's cover some of the common questions that have come up over the last couple of months. Number 1, delta E. In layman's terms, what is it and how do I use it to calibrate?
Delta E is a formula that the CIE came up with in order to quantify the error of the color from the specific target. There's been different ones over the years, DE76, DEUV, 1994. The current one we use in CalMAN is DE2000. And essentially, it's an easy way to quantify, like I said before, how far the measured color patch is from the target patch. And it's specified in a number, say 10 or 3 or 1. One other thing is delta E, the number, as low as possible. That's what your target is.
Okay, so here's another question. Why does CalMAN initially default to a gamma formula of setting BT1886?
BT1886 is the gamma specification created by the ITU in 2011. Before that, there was no real specific gamma specification. When we were all using CRTs, they had an inherent gamma of somewhere between like 2.3 and 2.4. So it didn't really matter. But now we have digital displays, and they can have whatever gamma you program into them. So the ITU came up with this specification BT1886, which also takes into account the actual black level of the display instead of just a theoretical 0 black. So then your content will look similar on displays that have different black levels if you target BT1886 as your gamma.
Okay, that makes a lot of sense. So what about for those of the people out there that still use a gamma formula for like 2.2 power or 2.4? I mean, can you still do this in CalMAN?
Yes, essentially you would just go into the gamma formula setting in CalMAN settings, the gear wheel, and pick power law, and then enter your target exponent of 2.2 or 2.4. A lot of people do this if they're working on a legacy project that was originally mastered with something that was calibrated to 2.2.
Okay, that makes a lot of sense. Here's another question that comes up all the time, which is what size pattern should I use on my display?
I usually recommend using full-size patterns for everything except OLED or plasma, or if you still have them laying around, CRT. Essentially, on an OLED, just like a plasma, they have like a brightness limiting circuitry where they can't make a full field white as bright as a small window. And since most content isn't a full field of white, we would use a smaller window that has a lower APL, average picture level, in order to more simulate what normal content would be when we calibrate them. And I recommend a window size of about 10% to 5% for plasma, OLED about 25%, CRT same with OLED about 25% window.
Okay, that's a good one. So let's say you have color grading or edit bay. How bright should the display be? This is something people ask us all the time.
There's different standards that are kind of conflicting, but the general industry use case and what people have given me feedback from the field is they set it around 80 to 120 nits. Anywhere in that range is usually acceptable.
Okay, great. All right, well, it looks like we've got our data here. Let's take a look at this display. All right, so it looks like the color checker has finished running a series of readings. I'm going to go ahead and move this pattern pop-up window out of the way so we can evaluate the Delta E 2000 chart. Looking at all these color points, you can see that after adding a virtual LUT to this display with calibration, this would be performing phenomenally. I mean, this is exceptional results. You can see all of the measured points fall within their target parameter. This is set to the 709 color space. The color comparator looks beautiful. All the measured values compared to the target values, they look almost identical. I have 2 green lights for average error and max error, so this thing's ready to go if I had a 3D LUT applied. So this is a cool little tool that allows you to run the free CalMAN ColorChecker software to see which mode is best, and then you can also apply a virtual LUT to see how good it could look if you added a 3D LUT somewhere in the signal path.